And a couple maybe details of previous studies that we've done internally that I think are very interesting to understand when thinking about how to solve this problem. The first is that even when you have ground truth data of what the user is trying to do, and you can get this with an able-bodied monkey, a monkey that has a Neuralink device implanted and moving a mouse to control a computer, even with that ground truth data set, it turns out that the optimal thing to predict to produce high-performance BCI is not just the direct control of the mouse. You could imagine, building a data set of what's going on in the brain and what is the mouse exactly doing on the table. And it turns out that if you build the mapping from neural spikes to predict exactly what the mouse is doing, that model will perform worse than a model that is trained to predict sort of higher level assumptions about what the user might be trying to do. For example, assuming that the monkey is trying to go in a straight line to the target. Mm-hmm. It turns out that making those assumptions is actually more effective in producing a model than actually predicting the underlying hand movement.
So the intention, not the physical movement or whatever.
Yeah.
There's obviously a really strong correlation between the two, but the intention is a more powerful thing to be chasing.
Right.
Well, that's also super interesting. I mean, the intention itself is fascinating because, yes, with the BCI here in this case, with the digital telepathy, you're acting on the intention, not the action, which is why there's an experience of feeling like it's happening before you meant for it to happen. That is so cool. And that is why you could achieve superhuman performance probably in terms of the control of the mouse. So for open loop, just to clarify, so whenever the person is tasked to move the mouse to the right, you said there's not feedback. So they don't get that satisfaction of actually getting it to move, right?
So you could imagine giving the user feedback on a screen, but it's difficult because at this point you don't know what they're attempting to do. So what can you show them that would basically give them a signal of I'm doing this correctly or not correctly? So let's take this very specific example. Maybe your calibration task looks like you're trying to move the cursor a certain position offset. So your instructions to the user are, hey, the cursor's here. Now, when the cursor disappears, imagine moving it 200 pixels from where it was to the right to be over this target. In that kind of scenario, you could imagine coming up with some sort of consistency metric that you could display to the user of, okay, I know what the spike train looks like on average when you do this action to the right. Maybe I can produce some sort of probabilistic estimate of how likely is that to be the action you took given the latest trial or trajectory that you imagined. And that could give the user some sort of feedback of how consistent are they across different trials. You could also imagine that if the user is prompted with that kind of consistency metric, that maybe they just become more behaviorally engaged to begin with because the task is kind of boring when you don't have any feedback at all. And so there may be benefits to the user experience of showing something on the screen, even if it's not accurate, just because it keeps the user motivated to try to increase that number or push it upwards.
So there's a psychology element here.
Yeah, absolutely.
And again, all of that is UX challenge. How much signal drift is there? Hour to hour, day to day, week to week, month to month? How often do you have to recalibrate because of the signal drift?
Yeah.